Welcome back to Statistics with Mr. Walton. Today we're going to talk about a one proportion z-test when it is two-tailed. So if we look at the example that is here, we will see that we are looking for the difference. Is there a difference? And that is what indicates that we're going to use a two-tailed test. So let's write our null hypotheses. H sub O of a proportion, H sub A, we still have a proportion. In this case, we know that it's a difference. So we have equal to and not equal to. And a certain variety of grass seed usually has a germination rate of 0.8. So 0.8 is our parameter of interest. Next, as I've said before, I like to use my summary stats. Okay, so for summary stats, I'm going to write them right underneath. What do we know? And of course, I'm sure you're thinking, but wait, Mr. Walton, which one's the claim? Which one's the claim? Well, let's say they said, test this claim. This is what we're interested in finding out. Is it true or not? Here's our claim. It's different. Okay, so we do that. We're coming back to our summary stats. We know that P is 0.8. We know that X is 307. We know that N is 400, which means that our P hat value is 307 over 400, which is 0.7675. You may use your calculators on this, obviously. We also need to know our standard error, which is the square root of P times 1 minus P over N, which if calculated correctly, we should get 0.02, which allows us to calculate our test statistic Z, which is P hat minus P over the standard error. So Z in this case is equal to negative 1.625. All right. So we have all of our summary stats, and then we should realize next up are the conditions. For our conditions, we have S. It is given that a random sample, underlined right here, so it is given that a random sample is used. For independence, I believe that's a V, it is reasonable to assume there are more than 4,000 seeds produced by the company. And that goes to our 10 times 400, which is our 10% rule. Therefore, the seeds are independent. For N, normality, can we say that since N times P is greater than 10 and N times 1 minus P is greater than or equal to 10, the sampling distribution should follow the normal model. Don't forget to show your calculations. So right underneath here, I'm going to show my calculations. I'm going to show 400 times 0.8 is greater than or equal to 10. I'm also going to show 400 times 0.2 is greater than or equal to 10. Okay, so I have 320 greater than or equal to 10 and 80 is greater than or equal to 10. Check, check, we're good to go. Then we want to have our continuation statement, and we want to make sure that we say that everything is good to go. So, since our conditions are met, I will continue and calculate a one proportion significance test. Awesome. And now we're ready to make our picture. For our picture, let's make sure we have our normal model. We have 0.8. We know that we have 0.7675. We're shading. And then we know it's two-tailed, so we need to shade on this side. Question for a lot of people is, how do we get that other number? Well, it needs to be symmetric. So if we are 0.0325 away from 8 to the left, we need to be 0.0325 away to the right. So that means we need to say 0.8 plus 0.0325. So this is 0.8325. Our probability statement is the probability that p hat is greater than 0.8325, or the probability that p hat is less than 0.7675, which we can combine and say that that's the same as 2 times the probability of p hat being less than 0.7675. And we calculate. Now, to get this value, don't forget, here's our p-value. 0. We know it's going to be less than 1. How do we do that again? Let's look at our graphing calculator. Our one-prop z-test is found by using stat tests number 5. Again, stat test number 5. Then I'm going to put in 0.8 for our proportion for our population. We're going to put in 307 for x, 400 for n, and we're running a two-tailed test, so we picked not equal to. And then I'm going to calculate. Once I do so, I find that yes, I calculated my z-score correctly. Yes, I calculated my p-hat correctly. And my p-value is 0.1042, rounded to 4 decimal places. So we're going to take that back over here, 0.1042. Now what do we do with that? We write our conclusion in context. Time for the money statement. Money. Since our p-value is greater than our alpha level, and remember we had 0.1042 is greater than 0.1. Now let's look back, because I think I left that off of the summary stats, right? Ruh-roh, left it off the summary stats. Let's pick my pink, go back to this right there so that I can say, yeah, Mr. Walton, come on, Mr. Walton. Alpha is equal to 0.10, right? And we're going to come back down, rocking and rolling. Since this is true, then we fail to reject H sub O. Okay, again, since our p-value is greater than our alpha level, we will fail to reject H sub O because it is not statistically significant, and therefore the evidence does not support the claim that there is a difference in germination rates. Hope this helps. I'll see you on class, or see you in class very soon.